Hello, today we are continuing our study of chemical formulas, and today we are going to discuss how to put together formulas in that particular way. The first lesson will be dedicated to how we're going to put together binary compounds. This is like the first category of substances. Binary ionic compounds, the first and second groups of chemical elements. To handle such a task, you must have knowledge of the charges that elements can exhibit in their binary compounds, according to the group numbers assigned to them in the periodic table. So, it is crucial for us to determine the precise location of the element on the periodic table, such as first, second, third, fifth, sixth, and seventh group. And in parentheses, I have explicitly written down the group numbers that are used in the extended version of the periodic table for reference. What will their charges be like? Hey, check it out. For the first group, the charge will be +1. What type of charge cannot be? You cannot have a negative one. If this is the second group of elements, then here it is +2. Accordingly, there cannot be a -2. In the third group, there is a +3, so as a result, a -3 cannot be found within this ion. Starting from the fifth group, here we have -3, minus acidity level, -2, and -1. Okay, let's form ionic compounds of the first and second groups, representing elements from the first and second groups. But let's see how it's going to be done. All right, let's take calcium and chlorine as an example. Let us examine the ring, which is located in our second group. Therefore, the charge of the ring will be positive in the ionic state. As for chlorine, its charge will be negative in accordance with this. And in accordance with that, here we can make use of such an uncommon rule known as the rule of the cross. And the rule of the cross will be depicted in the subsequent manner in this particular case, taking on the following form and structure. Well, there you go. Hey, check this out. This number 2 here acts as an index for chlorine, and this 2 here, well, it signifies the atomic number for calcium on the periodic table. However, we may not require writing the numeral 1 in the upcoming times as it is implicit. Therefore, the formula would appear as follows. Or in this particular case, we have the option to give a specific name to this particular substance. This specific compound is commonly known as calcium chloride, which is a chemical compound composed of calcium and chlorine ions. And I direct your attention to the fact that the suffix ending in this case will definitely be such a suffix. And that signifies that there are exclusively 2 elements present in this formula. There exist a total of 2 elements within this connection. Now I'd like to explain to you how not to formulate forms. It is not possible to place calcium 2+ in the initial position, for instance, and magnesium 2+ in the subsequent position, as per the given constraints. That formula will be totally wrong. First and foremost, it absolutely has to be a plus. Check it out, he's always in first place. And here in second place will always be the negatively charged particle. Moving it is equally impossible. Therefore, it is uncommon to write chlor 2 calcium in this context. This will also be incorrect because we agreed on the rules that we will strictly use plus initially, or cotions is written at first and strictly minus in the second position. So hopefully it's clear how we built this formula. Now let's take the next example, shall we? Let us come up with a formula for a substance that is made up of magnesium and oxygen. Okay, let's have a closer look. Magnesium is classified in the second group of elements, so its charge will be 2 positive. Oxygen is in our sixth group, and its charge will be 2. If we add up, we get a total charge of 0, which means this formula is correct, because the sum must be 0 without fail. We will designate this connection as an oxide, in accordance with the appropriate terminology and nomenclature for this particular context. And please pay attention, the suffix ending will also be identical, that is, just like it is here in this particular context. Following that, we can proceed to devise a formula for a compound that will be composed of sodium and bromine elements. Okay, sodium is found in the first group, thus its charge is +1 due to the loss of 1 electron. And bromine is in the 7th group, accordingly 1. In the grand scheme of things, we end up with a total of 0, so the formula is correct. What will it be called? He is going to be referred to as sodium bromide. That's the name he will go by. And the suffix ending, as we can see, is exactly the same. Let's give another example. Okay, we will designate this element as potassium and its compound as potassium sulfide in our classification system. Okay, let's check. Potassium is in the first group, so its charge is +1. Sulfur is in the 6th group, so it has a charge of -2. And then, following the cross rule, we get the formula K2S for potassium sulfide. Watch it again like this, and here's a single 1, but we do not write the 1. For this particular purpose, potassium sulfide will be the substance that will be used. And the suffix ending will be like that. Today we are going to learn how to construct compound formulas by utilizing the first and second groups of elements. Here they are, these elements. The oxidation state, as you can see, is +1, +2. And we ended up doing this for the following examples. I hope we've sorted things out with you and you understand it. And make sure to utilize the rule, the cross rule, if it is effective in the rule formula. Well, in the next lessons, we'll get to know how other compounds will be formed from different categories of metal. But that's all for today. Goodbye, guys.